process, I think. Right
Nice.
now started.
Okay. So good morning, all of you, and wishing you very happy New Year to all of you. And today we are going to start a wonderful session on the Docker. And in this session, we will learn about the basics of the Docker and the even the more than the basics of the Docker. We will perform all the basic commands. We will create the container. We will start container, stop container. We will discuss about the more things in the Docker session. So it will take a little bit time. It will this session could be the 2 hours or more than 2 hours. So keep your patience. We will also have the your questions to, if is there any, then we will try to resolve your query. So so first of all, I would like to thanks to all of you to join this session, and I also would like to thanks to Midun sir and the Krishna sir to provide me the platform so that I can share my knowledge. Okay, so without wasting the time, let's start. Let me share my screen. So I'm sharing my screen. So my screen is visible to all.
Yes, Rob.
Okay, thank
Yes.
you so much. Thank you so much. So let me put it on presentation mode. Yes, I think it would be visible to all of you. So first of all, welcome to in this session, and we will discuss about the Dockers. By this, we take the help of this presentation. I prepare this presentation and for you to describe the things. So before having the discussion about the Docker, we have to understand about the some more things. So we will discuss these things which we have already discussed in our last Kubernetes session. But here we will again discuss those things because without the basic understanding of the virtualization, we are not able to understand the containerization technology. So let's start. So the session timing, you know very well. It will go up to the 1 hour, 1 o'clock. So in this session, we will cover the theoretical session, the lab setup, and the practical as well. And so, what are the contents of this session? Is that we will discuss about the type of the services which we have already discussed in our last session, virtualization and its type. And we will discuss about the difference between the virtual machine and the container, and Docker and its history. And we will discuss about the Docker container, Docker image, Docker file, Docker port forwarding, Docker volume, Docker network, and Docker compose, and the lab. So in this 2 hour, we will complete all those things which you will uh, which you will it will take the around the 1 month. If you are going to take the training from the any institute, then it will take around the 1 month. So we will try to cover this in 2 hours, and also I'll ensure you, I'll make you understand uh, about the each and every terms which is mentioned here. If I will be not able to explain anything, then I definitely let you know. Oh, later, if at that time, at the moment, I will not be able to to make you understand. So here, let's start. So we have already discussed. We have in the IT services, we have majorly there are three types of the services. Other than three, we have also, but majorly here the word is written majorly. That's why these are the major IT services. So first is the IaaS, which is known as infrastructure as a services, and which second one is the PaaS, platform as a service, and third one is software as a services, SaaS. So these types of the services are majorly available, which is provided by the IT sector. So let's discuss about these services. IaaS means if you are creating an infrastructure, It could be on the physical hardware, it could be on the public cloud, it could be on the private cloud. If you are creating the infrastructure, so infrastructure is what? Infrastructure where you want to deploy your application. Suppose, for example, you want to deploy a website to the facebook.com or google.com or the whatsapp.com. So what you need some servers, you need some switches, you need some routers, you need the so many things in the network. So all these things are known as, are the part of the infrastructure as a service. If I am giving you the machine, the server, and the routers to deploy your application, that means I am providing you the infrastructure as a service. Okay, so I think you got understand about the infrastructure as a service on which you can deploy your the website. Okay. Now question is that the what is the PaaS and SaaS? So before discussing about the platform as a services, we will discuss about the software as a service. Once I have given the infrastructure to you to deploy your website, suppose you are saying that I don't have any kind of these types of the engineers who can deploy the website, which my company website, it could be sterlite.com, it could be the nokia.com, it could be anything. Suppose you want to start an organization, and you want to launch your website, and you are not able to, you don't have the manpower to deploy the website. So you are asking to the for this service. That means you are asking the software as a service. If we will talk about the software as a service, that means I am providing you IaaS service as well as the software as a service. So I have the team of the engineers, software engineers, who will develop your website and will deploy on your infrastructure. So this kind of the services are known as software as a services. Now question is that infrastructure is available with us and the software is also available with us. Then what is the need of the platform? So need of the platform is this: your application or your website could be more dynamic, could have the more functionality. It will be available, it should be high available. So these type of services are provided by the platform as a service. We will take some examples of these the PAS in the next slide. Here, the example of this PAS is, if you are deploying your software or your application on a physical machine or a virtual machine, that means you are not using the platform as a service. Okay, so if your application is running inside the Docker or like a Kubernetes, if you are using these kind of the services, that means your application is running on the platform. So which platform? Like Docker, like Kubernetes, like something else. So this type of the services are known as the platform as a service. In this slide, we will understand about the virtualization. So this is the same definition which I have given in your last this session on the Kubernetes. So what is the virtualization? Virtualization is the technique to add or split the physical resources into the virtual resources as many as we required. So physical resources is what? Physical resource could be a the hard disk, it could be a memory, it could be a CPU, it could be a NIC card, everything, whatever is available in your physical server, these are known as the resources. If we are adding the two physical resources into a single, that means we are doing the virtualization. Suppose you have the 32 GB one card and another 32 GB one card. Then if you have two memory card in your phone, suppose you have two memory cards in your mobile phone, and if you want to store a file which is of 40 GB, then you will not be able to store that file, because you don't have, you will get the message that the sufficient storage is not available, because these 32 and 32, but in actual you have for 64 GB space available in your mobile, but both are the reacting as a separate entity. So none of the storage card is able to store the 40 GB hard disk, 40 GB your file. So what you do, you can virtualize this. You can add this by doing the virtualization process. So it become a single entity. Then you can store the 40 GB file, you can store the 60 GB file, you can store the 50 GB file. Likewise, if you have the big size of your the server, or which is having the large number of memory, RAM, hard disk, and CPU. Likewise, you can split into the multiple uh, multiple part. You can say if you are creating the multiple virtual machine, then you can allocate the the resources, these resources to the your virtual machines by splitting these from single entity to the multiple entities. So this kind of things are known as the virtualization. Majorly, there are two types of virtualization. First one is the hardware based virtualization, and second one is OS based virtualization. We have discussed in our last session about these kind of the virtualization. So here we can see the examples of these virtualization. If you are using the OpenStack, VMware, Oracle VirtualBox, and Microsoft Hyper-V, that means you are doing the hardware based virtualization. You can also install the Oracle VirtualBox and the VMware on your laptop to create the multiple virtual machines. Okay, so second one is the OS based virtualization. So we will discuss about all those these virtualization, both the type, in the next slide. So OS based virtualization example is Docker, Rocket is nothing but it is a the containerization engine. And Docker Swarm, Kubernetes, these are the example of the OS based virtualization. So moving to the next slide, I hope you will got understand. So here we can see the hypervisor based virtualization, which is also known as the hardware based virtualization. So hypervisor is what? Hypervisor is a software that provides the functionality to virtualize the physical resources into the virtual resources. And second one is the containerization based virtualization. Here two pictures are depicted in your screen. In the left side, you can see the virtual machine, and the right side, you can see the containers. Here, the structure is a little bit different in the both the kinds of the virtualization. In the left side, where the virtual machine is available, you can see that there is a hardware, physical hardware, or you can say the bare metal. On the bare metal, on the top of the bare metal, you have to install a hypervisor. Why we require to hypervisor? Because we want to virtualize this. We want to virtualize this hardware into the multiple uh, virtualization machines. I want to allocate this hardware into the different virtual machines. Let me take the pointer.
Rajiv, it's a presentation view or it's
It's a presentation.
okay, thanks.
Is it not properly visible to you?
Oh, no, it's visible. Actually, on the right side, I can see the names who have joined the meeting. So,
Oh,
in the previous sessions, I see that this portion was less. So that's why I asked. No
no, no.
problem. You can
That's
continue.
presentation view. You can check your setting in your Google Meet. Okay.
Okay, no problem. Thank you.
Okay. So here you can see this is the virtualization machine, and this is the containerization. Here you can see this is our hardware, bare metal. On the top of the bare metal, we have to install the hypervisor. Then we can create the different virtual machines as we required. Here in this picture, you can see there are three virtual machines here. This one, this second one, and this one is the third. Whenever you will create a virtual machine, then you have to install your OS. So on this virtual machine, you can install the Windows. Here you can install the Ubuntu. Here you can install the CentOS. Whatever you require, as per your requirement, you can install your operating system. On that operating system, you can install all the libraries and your application, whatever the required as per your application. You can install all the binaries and libraries, or you can say the what is the word? I don't remember, sorry. So this is the virtualization process of the hardware virtualization process. So here you can see you are installing the operating system on your virtual machine. But on the right side, you can see the here this is the infrastructure, and on the top of the infrastructure you have to install the operating system, not hypervisor. Here this is just like your laptop. Once you purchase your laptop, then you install the operating system. So this is just like a similar like that. On this operating system, you are installing the container engine. Could be a Docker, could be a Rocket, or any kind of the containerization engine which is available in the market. But Docker is more popular. That's why always we say the Docker. So all when you create when you install the Docker engine, then you can create multiple containers like this on this. So you can see inside the container, operating system is not available here, because this container extract the functionality of the operating system from the Docker, from the container engine, from the host. So that kind of the virtualization is known as the containerization virtualization. So here you can save your the cost, because here in the left side, on every machine you are installing the operating system. That means you should have the licensed version of the operating system if you are using in the organization. So you have to purchase the license of the operating system for every machine. But if here you have to purchase only once. So here you can save your money. Moving to next.
Can you go back to the previous slide?
Yes,
Previous,
yes.
uh, previous one after.
Okay.
Yeah. So here you mentioned the OS-based virtualization, right? So as we are saying that container-based virtualization is the same OS-based virtualization.
Yes, yes, yes.
Okay.
Actually, container is performing the OS based virtualization.
Mhm.
Okay.
Hello, Raju.
Yes.
These OpenStack, VMware, and Oracle, all these are hypervisor.
No, no, no. These are the software. If we will talk about the VMware, where is it? Where is it? Let me check. Yes, this one. So VMware basically is a company, and it is having its software.
ESXi.
Yes. So ESXi is the name of the hypervisor in case of the VMware. If you will
Okay.
talk about the OpenStack, then I think KVM is the hypervisor.
Yes.
Okay.
So that means that is all these are the hypervisor, OpenStack, VMware, Oracle, all these things.
OpenStack, actually KVM is the only the part of the OpenStack. There could be a multiple tools as well in the OpenStack.
Okay.
This is just,
Inside the OpenStack, also the OS, host OS is also there.
sorry.
Oh, operating system is also inside the OpenStack.
No, no, no. On OpenStack, once you will install the OpenStack, that means the KVM is also installed. KVM means the hypervisor. And after that, you will create the virtual machine. Then you require the operating system.
Means
OpenStack or the hypervisor.
inside the OpenStack, KVM is also inbuilt.
Yes.
Okay.
So operating system is required when you are creating the virtual machines. Okay. Okay.
Hi Raju.
Yes. Yes. Yes.
Uh,
Pratap.
Go one slide back.
Mhm.
Can you elaborate a container engine, like if any container installing on the container engine and it's extracting the OS from the operating system which is already installed in the physical machine. So how it extracted those containers? Can you elaborate in detail?
This is the functionality of the container.
Okay,
Okay.
so can okay,
Whatever is required, then physical resources is required for the like the CPU, RAM, and the disk. Then that container extract the functionality of the uh,
uh,
that
OS.
extract, yes, extract the resources from the physical hardware with the help
Okay.
of container engine.
Okay, so as in our laptop, there is a physical machine. On that we install the operating system. On that we install the Chrome. Okay, and from Chrome we are going to search any web service. So it's like that process happen here also.
Chrome is installing. I'm not getting you. Whatever you want to
No, no.
say.
See, above the operating system, we install the container engine. Okay, in a
Yes.
similar
Yes.
way, we also install the Chrome browser. Okay, and after that whatever the containers are there here, so similarly we install the search the multiple websites. So how I can correlate all
So
this with the
you
prices?
you are saying if you are creating a container and Chrome is installed inside the container like this.
No. Matlab, I just want to visualize that if container is installing on in the container engine. Okay, so how
Mhm.
it's extracting the OS from that
So this is
container.
internal working now. Actually, container engine is used to create the container, remove the container, start the container. All these functionality is provided by the container engine. So
Okay.
as per the application requirement, suppose you inside the application you are running the SBC. So as
Okay.
per your SBC requirement, the resources will be extracted from the physical resource, physical hardware.
Okay.
So this functionality is given by the container engine. This is the internal programming of the container engine.
Okay.
Okay.
So, okay. So mostly which one use for that? That is first one or second one? That is, I think we call it as a type 1 or type 2 hypervisor.
Type 1 and type 2 is hypervisor is available in your hardware based virtualization
Okay.
only, not in containerization system.
Okay. Okay. Thank you.
Okay.
Hello, Rajiv.
Yes, yes, please.
We can use the hardware virtualization and container-based virtualization at the same time.
Yes,
Suppose firstly we have
yes,
done.
yes, you
Okay,
can.
Yes.
How
okay,
you can? Suppose you are installing the VMware on your laptop and creating a virtual machine. Okay,
mhm,
on that virtual machine, you can install the Docker.
okay,
Okay.
okay.
Raju, can you please explain the SaaS for the any real example?
Yes, for the SaaS, I have given the example. Suppose you are the owner of the Facebook.com. You
Okay.
want to launch the website. then and you are not having the team to deploy to develop this website, and then you will see, you will ask to do these things to the expert one. Okay, suppose I am the service provider. Okay, so you will ask to me ki I want this is my requirement. I want to create a social website which name would be the facebook.com, and I don't have the resources, so I need the everything from your side. Everything from my side means you are asking me to give the infrastructure, you are asking me to the platform, you are asking for the software as well. So this thing is known as the software as a services.
No, it is okay, but I want to know that in a real time we are using him now.
I think Gmail is the example of SaaS
Mm,
because Gmail or we are using on the cloud na.
Because software, the SaaS means ki any application is ready, just we go and use it.
yes, yes.
That
Right.
means Gmail
So
is SaaS
thus,
na.
I want some example also in the real scenario, if you have.
You are using Gmail, right?
Real example now, if I am developing the website for you, so that means I am providing
No, no,
the
no. I'm not telling you ki you develop my website for me.
hmm,
Just I want to know that ki what the SaaS part be using currently.
Any
it's
application you are using
Um,
on the internet.
yeah, yeah,
Any
yeah.
application.
yes, anything. Suppose you want to from my side that SBC or
Yeah,
MRF.
can you
Okay,
confirm that the Outlook is I think also the example of the SaaS?
yes,
Am I correct?
every application is the example of SaaS. Your
Okay, that's
Gmail, your
I want to
Facebook,
know.
your WhatsApp, anything.
Okay.
Okay, so okay, we have discussed more about the basics of the virtualizations, which is required to understand the Docker. So from here, we will start the Docker. We will discuss about the Dockers and its components. So first, we will start the definition of the Docker. So definition of the Docker we have already discussed in our last session as well. So Docker is what? Docker is an open source containerization tool. Containerization tool, that means it is capable to create the container, delete the container. Okay, so that's why it is a containerization tool. It is an open source. Why open source? Because you can take its source code and you can modify as per your requirement. So that's why it is known as the open source, which is used. Docker is a open source containerization tool which is used to create, deploy, and run the application. Okay, it performs the OS level virtualization, which we have already discussed, and it provides the platform as a service. Okay, so what about its history? It is its first release came in the market in the March 2013. 2013, it came into the picture, and it is developed by the Solomon Hike and the Sebastian Paul. It is written in Go language. This is the small history of the Docker. So we will discuss about the features. No pre-allocation of the resources is required. Whenever you are creating the container, then at that time, there is no need to mention how much RAM is you required, how much CPU is you required, how much hard disk is required. But in case of the virtualization, when you are creating the virtual machine, then you have to specify what is your resource requirement for that virtual machine. For example, you can see whenever you are creating the virtual machine on your OpenStack, then you have to specify what is the flavor. And the flavor is what? Flavor is the combination of the your CPU resources, your memory resources, RAM, and the hard disk and the network. These are the mention inside your flavor. So this is the basic difference between the virtual machine and the container. So container does not require the pre-allocation of the resources. As per the application requirement, it will extract from the host machine. It is
Rajiv, one
yes.
question I have. Can you elaborate the Go language little bit more?
No, actually, Go language, it's a language like C, C++, C Sharp, Java, but I am not able to explain that about the Go language
So
because
it's a product of Google or what? I think it's
yeah, yeah,
product.
it's a product of Google.
Okay, okay. Thanks.
So it's a programming language actually. We have hundreds of programming language. We have B language, A language, C, C++, Java, JavaScript, Python. Okay.
Okay, good.
Docker can run on the physical hardware, virtual machine, on and on cloud. So there is no specific requirement. It can run on your physical machine, it can run on your virtual machine, it can run on your cloud. Took very less time to create. Within the second, it create the container. Docker can run on any operating system like Windows, like Mac, like any Linux distributions. It could be a CentOS, it could be a Ubuntu, Kali Linux, or Red Hat Linux. It could be anything. So it is very compatible to for all. Use term in Dockers. There are few terms which we will frequently use in this our session. So we will discuss about those the terms. First one is the Docker host. So Docker host is nothing but on which machine you are installing the Docker engine or you are installing the Docker, that machine becomes the Docker host. If you are installing the Docker on your laptop, that means your laptop is Docker host. If you are installing the Docker on your virtual machine, then that virtual machine will known as the Docker host. So here one more term which is not mentioned here, a Docker client. So if you are Docker client is used to access the Docker host. For example, I am showing just a minute. To keep the link. Let me open the MS Paint. Here, this is your machine. On this machine, if you are installing the Docker, that means this is the your Docker host. And if you don't have direct access to work on that, then you will access from the other system. It could be your laptop, it could be your desktop. Then that machine is known as Docker client. So this is your Docker host, and this is your Docker client. Okay, so this I want to let you know. No, come on the slide. So Docker host we have discussed. Now image. So images are read-only binary templates used to create the container. If you want to create a container, then you should have a image. Without image, container cannot be created. Here I have given an example. Image is like a soul of the container, because without the image, it cannot be created the container. Without an image cannot be created. Like a human body, you can see human body is not having any existence without the soul. So likewise, Docker container is always required the image. So this is the example, so that you can correlate it with the our human body. So human body always required a soul, otherwise there is no meaning of that body. Okay, so likewise container is always required a, a image so that the container can be created. Okay,
Raju, I have one question.
yes please.
In what things in the inside the image that should create the container?
I will let you know. We will discuss more about the image. Just for the time being, you have to understand, without image you cannot create the container. Okay, I will discuss it the more about the images. Here one more term is container. Container includes the application with all its dependencies into the single deployable unit that can be used in the different system or server. Here you can see in the picture, there is this is the container. This container is having an application which is known as app, and all the dependencies. That means this application, whatever the dependencies is required, it is also available inside the container. But in case of the virtual machine, if you are running your application in your virtual machine, then you have to install all the dependencies. Dependencies is what? Suppose your application is required Python, then you have to install the Python. Your dependency is required the any other software, then you have to manually install it. But inside the container, if a container is creating, that it comprises all the dependencies which is required for that particular application. So if you this container will move from one machine to another, it will not ripple, it will not affect, it will simply run. But in case of the virtual machine, if you are giving the application to run to the other team like tester, then the tester team will install all the dependencies of that application again in his system. Okay, but in case of the container, you need not to install all the dependencies, because all the dependencies are comprised inside the container. So this is the main the functionality, or you can say the advantages of the container.
Rajiv, one question here. In case of the operating system means based virtualization, so it's take all the means the all the images or the softwares from the it use the operating system of the basically it use the operating system of the means it's not contained in the container. I want to say.
In OpenStack,
uh, anyone means the in the operating system virtualization, it's a container don't have all the dependency with it, na?
actually I'm
Because
not.
we are saying that container is a lightweight, means its size is very less or something like that.
Yes, yes. It
So
is
how say that it has all the dependencies? Means
it has all the dependencies in a you can say the all in the lightweight on the where it will run on that it will run only on the Docker host. It could be your machine Docker host, it could be on my machine Docker host. So it will extract all these functionality from that Docker host.
so it take all the means application from the host, na?
Yes, not
So
application is binding with the container. That
okay, okay. Application
image,
fine.
yes, image will having the set of rules, set of instruction that will be installed automatically inside this. Actually it is
Okay,
not
means
carrying this.
if we want to use the Python, suppose
Yes,
on the container, then the image has the rule of binding of the Pythons. So
yes,
it will use always from the operating system only. But
yes.
uh, yeah, okay, got it.
So one is the term which is Docker registry. So Docker registry is what? The Docker registry is the place where all the images are available, where you keep the images. That place is known as the Docker registry. Basically, there are two types of the registry. First one is the public registry, and second one is the private registry. Public registry is what? In case of the Docker Hub is the public registry. Likewise, Google is having its own Docker registry, its own the registry, and Red Hat has its own the registry. I don't know what is the name of their registry, but in case of the Docker Hub is the registry which is public. It is open for all. That's why it is known as public. And the private registry is what? Suppose you are an organization, you have some images which you don't want to disclose to other ones. Suppose you are the organization of Nokia. So Nokia is having so many images, but just because of the confidential purpose, that cannot be put on the public registry. So on that premises, they will create a server and keep all those the images in that server. So that server will known as the private registry of Nokia. So this is the basic difference of the public and the private. We will also access the Docker Hub in our lab session. I will let you know how it works and how it looks like. So one more term is Docker file. What is the Docker file? Docker file is the set of instructions. Set of instructions for what? Docker file is used to create the image. It is used to create the image. We have discussed about the image, but how Docker image built? So through that Docker file is just a programming file, you can say, where all the instructions are written. We will do some practical on the Docker file as well in our in this session. So here you can see the first we have to create the Docker file, and then we will build this Docker file, then it become the image, and with the help of this image you can create the container. So this is the process. So Docker file is nothing but the set of the instructions to create the image. Okay. So Docker Compose
Is the Docker registry, Rajiv?
Sorry,
What is the role of the Docker registry here?
what is the role of Docker registry? Okay, suppose you have created a image with the help of the Docker file. Suppose you create a Docker file and you create suppose for example you are creating the SBC image, SBC signaling image. Okay.
Okay.
So whenever you will use this, whenever you will deploy SBC signaling VM, then you will use that image. So
Okay.
that image should be keep in a place now.
Right.
That image will keep in the registry. So that registry will be known as the private registry.
Okay. Okay.
Okay, so that everyone can fetch this image whenever they create the virtual machine for the SBC signaling.
Okay. So we can say the Docker registry is the place where the Docker file is placed, right?
Yes.
Okay.
Okay. So Docker file is the set of instruction to use to build images. Actually, there is some hide here. Let me. Yes. To build the image, we use the Docker file to build the image, and we use the Docker Compose to build the container. We can create container by two ways, with the command line or by the Docker Compose file. So we will do some practice on both of these things. The basic difference here you can understand for the time being. The Docker file is to create the image, and Docker Compose to create the container. Okay. So Docker images can build majorly. There are two ways to create the Docker. Oh, sorry. Docker image. So first one is you can create a Docker file. You have to write the instructions to create the image. With the help of the Docker file, you can use this command docker image build -t and my image, or whatever you want to keep the name of this image. If you are deploying, you are creating the image for the SBC, then you can keep the name SBC image. Okay, this is up to you. So first way is to create the image from the Docker file. Here Docker file, if you will build this Docker file, then it will become a image. Next one is from the container. If you are having a running container, with the help of that running container, you can create the image as well. For this, you have to use the command docker container commit, and then the name of that container and the name of the image what you want to give the name. Okay, so these are the two ways. There could be other ways as well, but majorly there are two ways: from the Docker file and from the container you can create the image. Here we will see the
Hello, Raju. Can you explain again the building that image will have? Docker image building.
Docker image build. Just one.
Yeah.
Yes, we will perform this command in our lab. Till now, you have to keep in your mind, Docker image can be built by two ways. First one is from Docker file, and other way is from the container. Okay. We will perform all these the command in our lab. Then the understanding will be more clear. Okay.
Docker image building using the container, but we make the container using the image.
We make the container using the image. Yes.
Yes. But how you tell me that the container using the container we can
Yes.
no.
From running container, you can also create the image.
Okay, after you by using the snapshot like that.
Yes. This is the container. This is the.
Yeah, understand. We take the snapshot of this container and run in any other server.
Yes.
Like that, no?
Yes.
Okay.
Docker port mapping. We will discuss about the port mapping, and we will also draw an image on the MS Paint so that I can make you understand. Which is the port forwarding is why required. Inside the Docker host, if there are multiple containers are running, then they can talk to each other. Suppose two containers are running in your Docker host, then they can talk to each other. So there is no issue between this. But your application is running inside the container, then how you will reach from the outside the host, like internet? If the facebook.com is running in your container, if it is not accessible from the internet, then what is the use of the facebook.com? So for that purpose, we use the port forwarding, so that our application can be accessed from the internet. So this is the purpose. We will also perform the this thing in the lab, then the understanding will be clear.
Raju, 80 and 8080 port both are the same. Both are using for the HTTP. But why here put for 8080 is host port and container port?
I will explain
both
you. This is the host port, and host port, in host port there are 65,535 ports. You can take.
Yes.
Okay.
But I think both port are using for used for the HTTP.
Not
Yeah,
having much.
80 and yes, correct. 80 and 8080 both are using for the HTTP. Either you use 80 or you use the 8080. Both
80
are
port,
same.
80 port is used for the, I think, in Apache. It is a
I
default
don't know,
port.
but everywhere we use this like.
But in Jenkins, 8080 port is a default port.
So Rajiv, you are saying it's a host port, right? Host port. So the host port means it using the internet from the operating system.
Using the internet of operating system, not getting your
Host
point.
port means
I
hot
will explain you once we will use this command, then I will explain you. Okay.
Host port means I think the Docker port is there, right?
Yes. Docker machine port.
Yeah, Docker machine port and it's the container port.
Yes.
Okay.
So we will use the Docker volumes. Why? What is the purpose of the Docker volume? As we know, the container is ephemeral. That means it is not permanent. It can be deleted. It can have some error. If you are storing some data inside the container, then it is not permanent. So become it permanent, we have to use the Docker volume so that our Docker inside our Docker host, we can create the volume. If that container got deleted, then we can use that volume, that data once again with the through the other container. So this is the purpose of the Docker volume. We will also perform the commands for the Docker volume. So one more slide should be there, Docker network, but I think it is missed by me. So now we will perform some the commands.
Raju, this Docker volume is a third party volume here we used or what?
No, you can use the third party volume, but here we will use the Docker host volume. Okay.
So Docker host volume is called the Docker volume?
Yes. It is deploy on the host machine. I will
So that volume. So that volume we need to attach from the external how we need to attach. We need to attach.
We will mount this volume with our container.
But I think this the container is extract from this resources from the host OS.
Yes. Extract extract from the host the machine, but it is not stored on the host machine.
Okay.
For the temporary use, it extract.
Okay. Then for the permanent use, we need to use the Docker volume.
Yes.
So for the Docker volume, how we need to insert the new volumes? We create a new volume.
I will let you know in our lab section. Okay. So here we have completed our theoretical part. So all these things which we have discussed, we will perform all the commands. So it will take around 1 and more than 1 hour. So have some patience and keep watching. So as we have told, we have discussed that Docker can be installed on your physical machine, on your virtual machine, or on your cloud. So for the sake of the easiness, we will take the virtual machines from our AWS, which is a public cloud. So I will open and let you know how to create the virtual machine and how to ready our server. There are 31 candidates are with us. That's great. Okay, let me open on this window. Yes, login. Sign in.
Hi, Rajiv.
Hi.
Actually, we can practice at the virtual machine.
Yes, you can practice. So one instance is running, which is that. Oh, Docker is already running, but I will stop it and install and launch a one more machine so that you can easily do from your side. Here we are going to launch a virtual machine on AWS account. We can put the name of our machine. I am here giving the Docker machine. Where you can select the image. I am selecting the Amazon Linux, which is already by default selected, and the by default it is giving me the one CPU and the 1 GB RAM, so it is sufficient for our Docker. So I have my key, so I am using this. If you have not, then you can create from here. Okay, so I will launch here. Only one machine is required, so count is 1. So launch machine. View instances. It will take few seconds. Yes, now it is up. Here you can say there are 2 IP addresses are available. First one is the public IP address, and second one is the private IP address. So public IP address just to access the machine from outside the AWS, and public IP address is just to communicate these machines internally within the AWS account. So we will use this public IP address, and we can use the putty as well as the mobile extern, whatever you want, you are comfortable. So I am using here the mobile extern. Session SSH. We will paste that public IP address here, and the user is EC2-user, because we have taken the Amazon machine. So Amazon Linux user name is EC2-user. We will browse our key to access that machine. So here on desktop I have that key, which is yes, this one, my key number 3. Now okay. So this is login. Here you can see.
This key, this key means the space we have taken from the AWS.
Yes. Actually, this was already created with me. That's why I did not create again. You can create it when you are launching the instance. If you have some problem, then I'll let you know after the session. Okay.
Okay. Oh, okay. If we are using the private, means you have mentioned two, na, public and private. So if
No,
we are
these are
using
IP addresses.
private IP, then it is same key required.
No. For private IP, you are not able to access your machine from the internet or from any other machine. So I told you here the private key is used, private IP address is used to communicate the internal one machine to another inside the your AWS account. If you want to access this machine from the outside or internet or from your system or other machine, then you have to use the public key.
So my question is, if we use the private IP address, means we want to use the internal. then in that case we require this key or not?
No, you are not able to the access with the help of either key or not. You will not, AWS is not provide the permission to access from the private key. Then what is the meaning of the private and the public IP? So private IP is always for the internal communication purpose.
Okay. Thank you.
So in our machine we will edit some rules, inbound rules, so that our traffic can be come from the, here we will choose the all traffic and anywhere and save rules. Okay, here we have taken the access of our virtual machine. Here you can see the IP address is 172.31.33.60, and the IP address of our machine is also this one, 172.31.30.60. Okay, so we'll give it the sudo permission. Su and the cd. I will hit the if config command. It will show you the IP address, whatever I told you. Here you can see this is the NIC card ETH0, and it is having the IP address of the 172.31.33.60. What is the purpose to show this? I will let you know. Whenever we will install the Docker, then you will see more things here in this portion. That's why I showed you earlier before installing the Docker. So now we will install Docker. For that, what you have to do, you have to perform a commands. It is not much difficult as the Kubernetes cluster. It is very simple. So you have to install the Docker. For this, you will use yum install.
So Rajiv, if config is not mandatory command after sudo su?
No. It is just to check your IP address and all these things.
Okay.
Okay. I just showed you because here you can see only this portion. But after installing the Docker, there could be something more. Just
Okay.
difference. Okay. So with this command, Docker should be installed. So I'll hit. So Docker is getting to start to install in our virtual machine, which is running on AWS account. So it will take few seconds. Yes. Now you can check the Docker is installed or not. You can hit the command which Docker. Then you can see, yes, Docker is installed here. You can also check the Docker -- version. Yes, Docker is installed with the version of the 20.10.17. Okay, so Docker has installed, but it is not, its engine is not started. Its engine is also known as Docker daemon. So Docker daemon is not started. So we have to start that Docker daemon. So to check if it is started or not, we have the command systemctl status Docker. Then you will see it is dead, inactive. Here you can see. So we will start it. For that, just we have to hit the command Docker start, sorry, systemctl start Docker. We will also enable this so that whenever we will open the virtual machine, so Docker engine always be start. So this is the purpose of enabling Docker. So Docker daemon is enabled. Here you will see the status. Then you will see the status is running here.
Rajiv, what is the system CTL?
It is a Linux command.
Means in the background we have another means the
It is not
platform.
related to your Docker. It is the Linux command just to start your Docker engine. If you install, suppose Apache, you have to start the Apache engine, then you will again use the system CTL.
Hello, Raju.
Yes.
This container D is this is the daemon.
Yes.
Container D dot sock.
Yes. Yes.
This is the daemon name, na? Of
Yes.
container.
Yes. Okay. Now we will hit the command if config again. Here you will see before installing the Docker, then the output was this portion. Now one more thing is added here, Docker 0. So inside the Docker 0, you can see the one subnet is available. So subnet is what? Is 255.255.0.0. Okay. So here this is the IP range. Whenever we will create the container, then the IP will be picked from this pool. This is the IP address which is provided by the, actually in backend there is a bridge created. The subnet mask, the subnet of that bridge is 172.17.0.0/16. So whenever we will create the container, the IP address will be picked from that pool. I will show you how it will picking and how we will check. So just to show this thing, I hit the if config command before installing the Docker and the after the Docker. So otherwise you got confused from container is the IP getting the from where the container is getting the IP address. So okay, so we have a sheet of all commands. So we will perform all these sheets. We have performed this part. We have performed this version and help. So Docker -help. If you will hit this command, then you will get all the commands which we can use in the Docker. So these are the parent modules. These are the parent commands, and these are the child command. We will use Docker container, we will use Docker build, we will use Docker image, we will use Docker network. All these things we can use. But after that, if you are using this command, these are the child command. Suppose if you want to check the list of the Docker containers, then you have to use Docker container ls. Where is ls? Ls is available here, I think. Ls is not available. ls. Okay, no issue. Docker container you can use attach. Docker container you can use cp. Docker container you can use event. Docker container exec. So these are the parent modules and these are the child modules. We will perform most of these the child and the parent modules. So
with any parent, we can use any child command.
no. For every parent, these child will not run. Okay, for the specific.
No. I'm telling you, I'm taking the SWARM. Then we can use any child command.
No. If you are suppose using the container, then some of these child commands will be applicable with the container. If you are using the network as a parent, then some of the commands will be applicable for the network. Okay.
Then how we know that which parent is working with which child?
You have to read this
Enlarging.
detail. You have to read
Okay.
this detail. The detail is given in front of the every child.
Rajiv, by which command we get these details? These
Help.
commands?
Docker hyphen help.
Okay.
You can also refer the documents here. Official document docs.docker.
Raju, if we use the CentOS, then I think the content this container D installation I think different.
In CentOS.
Yeah.
No.
Rajiv,
Yes, it could be a little bit different. If you are using the window, then you should have
No,
the
not window. I'm telling the CentOS Linux if
for
I'm
for
using.
for the Linux distribution. I think it is same for all the distributions in the Linux. Here you can see in this document. This is the
Because
official.
inside the AWS the this container Docker is also available, I
Mhm.
think, but we need to install in case of CentOS, I think.
Maybe.
As like you have done before in the Kubernetes,
Mhm.
you had take the some images from the you pull the images for that creating the container. No. For the daemon for the daemon in the Kubernetes.
As I think I did not pull any image.
You have put the stuff, some command for the installation from the other things, but we have given only one install docker -y and container D has been installed. But in CentOS case, I think something
Correct. It
different.
could be different, but we will discuss. Otherwise, our session will be.
No issue. You will discuss, no issue.
Yes.
Just
Rajiv, can you ping this link in the chat box, please?
This one.
Yeah, this one.
Yeah.
Thank you.
So this is the document which you can refer. Here you can see the Docker container attached. So Docker container is the parent and attach is the child module. Okay. So Docker container commit. Container is the parent and the commit is the child. CP, create, diff, exec. So here you can see. Okay. So don't why not to waste the time over. So we have to perform some commands so that I can show you. Okay. So to check how many containers are running inside our the Docker host. So for that, you have to perform Docker ls. Here you can see Docker ls. Just a minute.
unless it's not here, you say it.
Okay. Sorry. Docker container ls. If you will hit this command, then you will see there is no container is available here. Only the headings is available. So this command show you all the running containers. It may be the some stop container to show that those all those containers. So you have to specify hyphen a. Hyphen a means all. So here when you hit this command, then it will show all the containers. But right now there is no container. That's why it is nothing is available here. So you can also use docker ps command to show the container, docker ps -a to show all the container. Either this command or this command you can use. Okay, docker ps or docker container ls, it is up to you. Okay. Yes, if you want to see the images, how many images are locally available in your host, then you can use docker images. There is nothing no image is available, or you can also use Docker image ls. Okay, whatever you want to use, it is up to you. So now we can pull the image. It is not necessary to pull the image to create the container. If you are creating the container, then it search locally for that image. If it is not available, then it is fetched from the Docker hub. Okay, so if you want to pull the image, then you can hit the command docker pull image, name of the image. Suppose you want to Ubuntu image. Docker image pull. Sorry. Docker image pull and the name of the image. So this is the name of the image. Docker image is a the parent module, and this is the pull is the child module, and Ubuntu is the name of the image. Here you can see the image is getting start to pull from the Docker hub. Okay, now you will do the Docker images, then you can see you have one image. Okay, so this
How
way
we can how we can know that it is means taking the image from the Docker hub or the from locally?
Docker is internally the take you automatically on the Docker hub,
Okay.
because this is the public repository.
Raju, I did not get in, give any path
Yes,
from
yes.
where the image
Because
was
at the
stored.
time of the Docker installation, already the path is the mention in the its programming.
Okay.
By default. You can also push your image on the Docker hub. Let me open the Docker hub so that I can show you. Mehta, can you please mute your mic? Docker hub login. It is not necessary to have that account on Docker hub to create a container. It is necessary only when you are pushing the image, your own image, then it is necessary to have your account. Okay, so this is my account, and the user, the ID of this account is the Rajiv Shakya 687. So this is the my account. Here, from here, I can I can fetch any image, or I can pull the image. If we will check the image Ubuntu, then you can see the number of images of related to the Ubuntu. Then these are the mention in the Docker hub. Okay, so how we push the image, then that will discuss later. But before that, we will start how to create the container. Okay, so let me clear screen. Yes. So to create the container, you have to perform the command docker container run and the name of the image Ubuntu. Suppose. So Ubuntu is currently it is available in the Docker host. So that's why it is not try to fetch from the Docker hub. So it will create the container by using that image which is available on the Docker host. Here you can see the Docker container already created. We did not mention here, just we put the Docker and the container, which is the parent module, and this is the child module, and this is the image. We did not given the name. It is not necessary to give the name. How we can check Docker container ls. You will see there is no container. Why? Because it container created and goes into the exit mode. If we will do hyphen a, then you can see the container is created, but after the creation of this container, it goes into the exit mode or stop mode. Why? Because we not created it as a the interactive mode. That's why. If you want to create the container again, and if you want to uh, this container not dead for the 30 seconds, then you can write here sleep 30. So this container will create and will live for 30 seconds. For these 30 seconds, our terminal will be engaged. We will not able to do anything on this terminal. Let's see. Here you can see we cannot do anything. We cannot perform any command because terminal is engaged for 30 seconds because container is running. So after 30 seconds, it will exit. It should be exit. Yes. So after the 30 seconds, the terminal is free. So if we will perform the Docker container ls-a, then we can see here the two containers are available, which is in the stop mode. Okay. So what we can do, if you want to keep it alive, then you can use hyphen IT. IT means interaction mode. When I will hit this and the enter on this command, then a container will create and we will move inside the container. We will move inside the container. Here you can see the host name of this, our host is this one. And once I will hit the enter, then we will go inside the container. So host name will be changed. Hyphen IT. Why it is not running? Short flag.
Iteration is there.
Command is okay. Then why it is reacting like this? Yes. Here you can see that before hitting the command, we were in this host name. Now the host name has changed. That means we are inside our container. So if you will do ls, then you can
What
see
is the IT?
what is the IP. I will let you know.
No. Run hyphen IT. What is the IT?
IT, okay. IT is interactive mode. You want to interact with the container. Okay. So here you can see we are inside the container, and inside the container all the directories which are available in our normal machine. So these all are available here. Okay. So if we want to come outside this the container, then we can type exit. If we will do exit, then this container will again stop. So if you don't want to stop it, then how you can come outside this without stopping? Then you have to use the command, use the keypad control PQ. Now you can see the Docker container ls-a, then you will be able to see two container already stopped, which was earlier stopped, and one container which we created right now that container is still up about a minute, लगभग 1 मिनट हो गया है तब से ये up है. The name of this container is this. If we are not giving the specific name, then the Docker host randomly take the name by itself. Okay, now we will give the name of the container to create at the time of the creation. So this is the command to go inside the container, and if you want to create a container but don't want to go inside the container, then you have to use the -d for detach. It is the detach mode. Container will be create and it could be live and you will be outside the container. So whenever I enter the command, then container is created. If you will do ls-k, then you can see 2 containers are up. One is created before the 6 seconds, one has created before the 2 seconds. Here you can see the container ID. Every container when create, then it has its unique ID. The image, whatever the used at the time of the creation, the command which is performed inside the container, created, and the time, the status, and the name. So these are the detail of the container. Okay, now if you want to create the container with your specified name, then what you need to do? Let me clear the screen first. So screen is clearly visible to you or no?
Yes.
Okay.
Yes, Rajiv.
हाँ
Yes.
हाँ दिख रहा है.
Okay. Hyphen name, the name whatever you want to. Suppose mycon. The name of my container is mycon, my container. So you will see the container will create with the name of mycon. So if you will do container ls-a, then one more container is created with the name of mycon. So I think there is no doubt in till now. So we use the Docker container ls, we use the Docker run command. Now we will use how to create, how to start container, how to stop container, and how to remove the containers. So there is a command to remove the container, which is Docker container rm and the name of the container. So or name of the container or ID of the container. Suppose if you remove with the name of the container, then you can copy the name and then you can hit the enter. So with this command, this container deleted. You can check with Docker container ls, this container is deleted, removed. Okay, but if the container is running state, then this command will not work. So our running state containers are is
What is this no stack leak? What is
this
this?
is automatically name picked by the Docker host because we did not given the name at the time of the creation of the container. I told you.
Okay. If there is no name, then we
Then it
need
will
to put
take the
this command.
automatically. Yes.
So which container it delete? All the container it will delete
This
or
one,
only one?
this one container. This
Okay,
one.
it is the default name given by the
Yes,
system.
yes.
Okay,
Now,
okay.
now I will try to remove the container, mycon container, which is in running state, which will not be removed by this command. Here it is throwing an error. It is saying this container is in running state. So even if you want to delete this, so command will be same. Then you have to mention the option -f. -f means forcefully. You want to remove this container forcefully. Then this container will be removed. Here you can see this container removed. You can also see the Docker container ls-a. Here you cannot see the mycon the container because it is already deleted. Okay, so this is the command to remove the container. If you want to remove the stop container, then you can use docker container rm. If you want to running container forcefully, then docker container rm-f. Okay, so if you want to remove all the containers in a single command, then what you have to do, docker container rm-f, then dollar, then docker container ls-aq. If you will perform this command, then all the container will remove because you are using the option -f. Then all the running, all the stop container will be removed. Okay.
Raju, here all command doesn't work if we mention -f all. -f all command doesn't work here.
-f all.
Yeah, for deleting, for removing all the containers, can we mention that rm space -f all? So then it could be all container will be deleted like that.
No.
You need to mention this command, that is $sign command.
So by this command, you can see all the three containers. Either it could be in running state or in the stop state. All these container stops. You can check docker container ls-a. There is no container available here. Okay, so let's create some more container to perform other command. Docker container run Ubuntu. Okay, one more container. Okay, one more container. And one container in the running state -it-d and some name, suppose icon 1, and the name of the image. So here you can see the list of the containers. Yes, there are 4 containers are available in our Docker host right now. And out of these, 1 container is in running state and 3 containers are in stop state. Okay, so if you want only the stop container in a single command, then there is a child module is prawn, which is docker container prawn. If you will hit this command, prawn, spelling galat. Where is it? Prawn. P-R-U-N. You will hit this command, then all the stop container will be removed. It is asking, are you sure? I told yes. Then all the stop container will be deleted. You can check with this command. Only the running container is available and the rest all the containers have removed. Okay.
What is the full form of the PRUNE?
Prawn is not the short form of anyone. Prawn just to remove the stop container.
Raju, those containers are stuck. Can we make it restart? Is it possible?
No, those container is not can be restart because at the time of the creation there is no interactive mode was there. Suppose this container is running. Now I am coming on that point. This container is running, and if you want to stop this container, and then you can start your container. How? Docker container stop. You can mention the container ID or the container name. This time I am using the container ID, whatever you can use.
Okay, at the initial stage means those container we have made to means those container are in start state, means those container we have created in start state. Only with that we can change its state. Correct?
If the container is not creating in interactive mode,
Okay, interactive. Okay, okay, yes, yes.
yes, that container will never be the start. It
Okay,
will start with the help of the start command, but immediately it will stop.
okay, fine.
Okay. So if you will see, before hitting this command, that container was in the running state. Now it become in the exited mode. That means it is in stop mode. So how you will start it? Just to the mention here start and the container ID or the name of the container. Here you can use this few unique uh, characters as well. It is not necessary to mention the complete container ID. I will show you. Here I am taking the 4 characters, then it will work. Yes, it has started. You can see the Docker container ls-a. Now you can see it is up before the 6 seconds. Okay. Now you can also restart your container. So there is a command restart, the name of the container or container ID. Now I am giving the con name of the container, which is con1. Then before hitting this command, you check the Docker container ls-a. The container is running from last 45 seconds. Now I will run the restart command.
Then what is the purpose to create the container in the exited state? Is there any purpose?
There is no purpose. I just showed you.
Okay, fine.
No purpose.
Okay, okay.
So it will restart. So before that, that container was running from last 45 seconds. If you will hit this command, then that container will get restart. It is taking few seconds to get it restart. Yes, it is restarted. If you will check, the container is up from the last 3 seconds only. Okay. So we have performed the commands. Yes, yes. C command create Docker container, create new container. Okay. Kill. Okay. There is a command which is kill. Kill command is just like the prone command to stop the container. No, not it is like a prone to stop the container the forcefully. If your container is running, then you can use the kill command mycon1. It will stop your container forcefully. If you will stop, then on the place of the kill, then the container will stop gracefully. If you will use the kill command, then it will stop forcefully. So only the difference. Here you will see your container in exited mode. Okay.
What is the spacing in the bracket? That is 137.
This is the I think internal code. I
Okay,
don't
okay,
have
fine.
any idea about it.
Okay. Means it's not useful. Okay.
Yes, yes. Start. So our container has started. So let me check where we have reached. We have performed this one. Okay. Okay. Now exec and attach command. So your container is running. Now, if you want to go inside the container, then you can use the attach command or exec command. So now we want to go inside our container. So for that, Docker container exec -it, this is an interaction mode, and the name is my on one. Yes, you have to give the bash shell so that container can run inside the bash shell. Now you are the inside your container. Okay. So with the help of the exec command,
Raju, what is the meaning of exec?
exec means executable.
Okay, yeah, okay, thank you.
Okay. So now you are inside your the container. You can create a file inside the cd temp and touch abc one and if you do ls, then you can see there are 10 files have created inside your the container. In which folder? In the temp folder. Okay. So
Can you clear me after the IT Micon one bash? Why we use here bash?
bash is just providing to the shell a terminal so that container can be open on that terminal.
Okay. Means like immediate effect where
Yes,
we seen.
yes. So we will exit from, we have done the work inside our container. Now we want to come outside the container, then we will hit the press using the key.
Raju, if I want to run my application inside this container, then how we can run?
I will let you know. I will let you know. Just wait for a while.
Okay. Okay. Thank you.
Okay. So I will try to give all those the basic things at least so that you can create a big scenario, a big picture in your mind.
Yeah, thank you very
I will
much.
try to cover all those things. Okay. So it will take a little bit time. So this is the exec, and you can also use the attach command here. This is the attach command. Now we will go inside.
Without using bash, can we go inside the container?
Yes, if you will
Okay.
attach, and the name of my container is my own one. Why it is not working? Attach spelling is grave mistake. Now again you are inside the container, so you can check ls temp. In temp folder we have created 10 files. We can check, yes, there are 10 files. Okay. So now we will again come outside the container so that we can perform other commands, because there's so many commands are remaining and we have only 10 minutes, so we will cover it. We have performed the stop command, start, restart, stats. Okay, so what is the stats? Docker, sorry, container stats and my name of the container. With this command, you can check the CPU utilization, memory utilization of your container. Okay, so stats is used to check the statistics. You can also use Docker PS. No, Docker. No, not PS. Okay, top. So top command is Docker container top. Icon 1. Here you can see the how many processes are running inside your container. So it will show the all the list with the PID, processing ID. So this is the purpose of the okay. Now one command is important, which is inspect. Docker container ls-a. So one container is running. So if you want to check the detail of this container, then you can use the Docker container inspect and the name of the container. Inspect my on one. If you'll hit the enter, then you will get all the details of about this container. Here you can see. Okay. So this container is in a running state. It is true. It is not in pause space state. That's why it is written for false. The image name, container ID. Okay. So this is the ID. So these are the information which is written inside. Here you can also see the IP address of the container. Here you can see 172.17.0.2. I told you in the beginning, the IP address will be picked from the pool. So our pool was what? 172.17.0.0/16. So the first allocated IP is this, but it is not permanent IP. It is not static. It is remove. If you will stop this container, then this IP address will be released. This IP address will release, and you will create another container. So this IP address can be allocated to that container. If you want to check only the output of the IP address, then you can use grep I another IP address. Here you can see the only IP address is written. So if you are creating another Docker container, run -IP -name my on 2 and image is Ubuntu. Yes, it is created. Control PQ. If you will see, if you will do the inspect for the mycon 2, then you will see the IP address of this is the next IP address of the previous one. Here you can read 0.2. Here you can see 0.3. So like this, the IP address can be picked. Okay. Now stop the container. First one container mycon 1. Then we will see the container stop and name of the container, which is mycon 1. Yes, it is stop. Now we will check the IP address is available there or not. Here you can see the IP address is not available. That means this IP address has released. If you'll create an other container, then this IP address can be allocated to the that container. Okay. If you will start, it is this the same container, then it is not necessary to give this IP address. It may be assign this IP address or it may not. Okay.
Raju, it means in the real scenario, we need to provide the static IP.
Yes. How we will can provide, then I will let you know. Container start from 1. It started. Let's check which IP address assigned to mycon. Yes, the same IP address assigned. But if it was the engage with the other container, in between we create another container. If this is allocated to the other, then the new IP address will be assigned to this one. Okay. So actually this was available. That's why it is same assigned to. Okay, let me check the sheet, whatever we have covered. Okay, one more command is remaining to delete the image. So to check the images, docker images command. Here you can see we can also pull docker image, pull send os. Docker image pull nginx. Now we will check for images. We have 3 images now. So how we can delete these images? For that, docker image RMI and the name of the image. Suppose you want to delete the CentOS, then you have to write this name or the ID of the image. Here the ID is mentioned. Okay. So this is deleted. You can check docker images. You can see only 2 images are available. Okay. So there is another command. If you want to delete all the images in a single command, then you can use this command. So I am not performing this. So now I am moving forward to the how to create the image. We have learned um, how to pull the image. Now we will start to learn to how to create the image. So image can be created. Image can be created with 2 ways in the theoretical portion we have discussed. One is from the container and one is from the Docker file. So from the container, how it is created. So we will check. Docker container plus -. There are 2 containers are running. So with the help of any of container, we will create the our image. So for that, you have to use the commit command here. So docker container commit and the name of the container and the name of the image. Suppose you want to create the image from the mycon container and you want to keep the name. It's my image one. Whatever you want to give the name. Okay. So if I'll hit the enter, then the image will be created. So before hitting this command, I want to show you the list of the images which are available in our Docker host. So I will do the Control C and hit the command Docker images. We have only 2 images. Okay. So with this command, one more image will created. Docker container commit mycon1 and the my image. Sorry, 1. Yes, it has created. You can check the Docker images. Here you can see the image has created. If you want to create the container with the help of that image which you have created, then you have to just hit the same command. Only the difference is you have to change the image name. How? Docker container run -80 and -name. Name is suppose my on 3 and the name of the image. Now I am creating the image, creating the container with the help of image created by myself. Image 1. Here you can see your container is created and you are inside the container. Okay. If you do ls, then control PQ. Now we are outside the container. You can check Docker container ls-a. There are 3 containers are running. These 2 containers are created. This one and this one created by the Ubuntu image, and this container is created by the my image 1, which is created by me. Okay, so likewise, we can create.
Well, sorry, Thoda. Can you tell me that how you create this image, my image one?
With the help of commit command. Let me show.
Which command?
Let me show.
Docker container commit mic
Yes,
on that.
this one. This is the Docker container commit. This is the parent module. This is the child module. This is the name of the container by which you want to create the image. And this is the name of the image, whatever you want to keep. The name. Got it?
Okay. The inside what the things need to be put. How we know that?
You want to see the image?
No. You have created my image one.
Yes.
Inside what things we need to put there? How we know that and how we need to select that? Yeah, we need to here make one repository like that.
Hi Rajiv. I think he wants to know that what are the coding and what are the what we call parameters are inbuilt inside the my image one.
No, just we need to put only my image name and but inside what the things is inside there.
All those
How I know.
are all those things which application is running on your running container. Suppose, for example, you are create a container. Let me complete. I think you will got understand. Suppose you build a container like icon 1. Okay. So inside icon 1, please mute your mic, please. So now you will go inside the icon 1 in the container, and then if you want to install the another application like Nginx, like Apache, like anything else, then that container, if you will create the content and the image from that container, at that time that image will contain all the functionality which you have already installed in that container. So that means if you will build the container with the help of that image, then you need not to install Apache 2 again. Got it? Suppose you want to create an image for your SBC deployment. So first what you will do? First you create a container, like on Ubuntu you have created your container. Then you will install the multiple softwares like the signaling for the media, for the there are so many things. Okay, so you have installed inside your container. Then from that container you will create the image, and after the creating that image, if you use to create the container with the help of that image, then you need not to install again the SBC software. So all the functionality will be available inside your image which you have built. Got it or not?
But how we know that which functionality inside the my image
You have
one?
to give the name likewise. Here I am just the sake of the easiness, I am giving the my image. If you are creating the image for the SBC signaling, then you have to give the name. This is the image SBC signaling version this and this. If you are
I put there in my image signaling. Okay, but inside what the content is, the content is there. How we know that and how we decide that what is content inside there?
So by likewise you are not able to see the what are the functionality. If you are creating the container with the help of the Docker file, if you are creating the image with the help of the Docker file, then you can see all the codings. Now I am moving to the how to create the Docker file and how to uh, uh, build the image from the Docker file. So where and in the Docker file you can see all the functionality, all the set of commands you can see there. In the image you are not able to see what are the coding inside the image.
Raju, Raju, hi Raju.
History, I think history, Docker image history, I think.
Yeah, it's done by the DevOps, right? All the image backend,
What
image backend, all the coding done by the DevOps team.
inside what?
What are the codings of the images of Docker images done by the DevOps team?
Yes, yes, Docker team actually.
Yeah,
So okay, now we will create the image from with the help of the Docker file. A small Docker file is written here. We will use this Docker file and I'll make you understand what is written inside this. So for this, we have to create a file with the name of Docker file with the same name, with the same. D should be capital and everything should be in small, because Docker engine is understand only this format. Okay. So now we are inside the this file. Now we will write the code. What is this? Here, these are the modules of this. This is the just a syntax you can use from what is the base image you required inside your image. Here I am saying Ubuntu maintainer, who is the building this image. So you can write here the name of the maintainer, and here we are performing some commands with the run module. Here you can see the run, expose, cmd, from. Okay, so these are the some on the modules of the Docker file. Here in front of the run, you can get there is a command apt get update -y. That means whatever image, base image, Ubuntu we are using. So first it will install, and then that that image will update that Ubuntu image, this base image, with the help of this command. It will update, and after that it will install a Apache 2. Suppose here Apache 2 is not available, you are deploying your own applications. It could be a SBC signaling, SBC media, MRF P, MRFC. It could be anything. So here we can give the instructions and exposing the port number here. And I am writing something. Hello friends, welcome to the Docker classes inside the this file. So all these things we can perform manually by creating the container with the image of Ubuntu, and then by going inside that container, we can perform all these tasks. But if I am giving inside the image, that means you will uh, get your container ready. Your application will be deployed. So that means here my application is Apache 2. I am deploying a website. On that website, it is written, hello friends, welcome to the Docker classes. Okay, got it? So now we will close this file.
Normally, it's like that we create the image file, huh?
Yes. What happened? It is not getting close. If you do ls, then you can see the Docker file. So what is the Docker? How to build it? So we have the command docker image build -t and the name of the image and then the dot. I will let you know all the meanings of this command. Docker image build -t is there now. Yes. T, and suppose you want to give the name of the image Apache to image and so this is not just the name of the image. You can keep by yourself anything, and image is the parent module, this is the child module, and dot is representing ki docker file is available on the same directory where you are working. Okay. So if you hit the enter, then it start to create the image. Here you can see first it is performing the first step, which is written in the from, then run. This is like, so step by step all the things are yes. The echo command run. Okay, now successfully build this image. How you will check? Docker images, sorry, Docker images. Here you can see this image is built by the Docker file. Okay, this image is built by the Docker file. If you will create a container with the help of the Ubuntu, then you will not see all those functionality which we have given inside the Apache 2 image. That means Apache 2 will not be installed in this container if we will create the with the help of Ubuntu.
Raju, last you told me that the Docker image build. This means that what image I prepared that we need to put inside the Docker.
Inside the Docker, inside the container for creating container.
No, in Docker image you
Store in
have
your Docker
made
host.
the
All these images are will store in your Docker host in your.
store in the means build means matlab I am putting my images in the inside the Docker, like correct?
Docker host.
Yeah, Docker host.
Yes. Okay. So if you will check Docker container ls, here 3 containers are working. Okay. So this container is created by Ubuntu. Okay. So if we will go inside this container, Docker container exec -it and the mycon1 and the bash. So you can check here. Now you are inside the container. Here you can check the inside the. You will not get the Apache here. For that, what you can do? cd in where there should be a directory www, but in this there is no directory of www because it is created when you install the Apache 2. So here you can see in when we do the ls, perform the ls command inside the where, you can see here there is no www directory. Okay, let me open the duplicate terminal. Because sudo cd. Okay, let me create another container with the help of image which we have created with the help of Docker file. Let's -a. First we check there are 3 containers are running, and what is the Docker images? Remove the name of the image. Okay. Now we will create the image with the help of this. Okay. Docker container run hyphen IP hyphen name, suppose hyphen 4. Okay. Now we will mention the image, this one. Okay. Okay. So one more thing I am doing here, giving the port. Don't worry, I will explain you just to show you. You told me how to we deploy our the website, our application. Okay. So if I will hit the enter, then a container will be created and it is exposed on the 8080 port. So you can check with the help of the IP address and the port number, you can access the the running application which is running inside the container. Okay. What is it saying? Docker container run hyphen rt hyphen name. Okay. Fully qualified domain. Starting Apache HTTP web server Apache 2. Is exited. What is exited? Docker container run hyphen name equal for 2. I think there is some issue. Docker. Can you mute your mic, please? Docker container room. Yes, delete it. Yes. Now we are inside the our this container is created by with this image, which is the Ubuntu image, and this container where we are inside, this container is created by that image which we have created with the help of Docker file. So now you will do ls. Here you can see the where inside the where you will see the www folder. Here you can see, but here you will not see. That means the Apache 2 is installed here. Here you can see, you can check with the help of the cat command here www and html, and the index file will be there, which will have some content which is hello hello friends, welcome to the Docker classes. So this website is hosted by default. I did not install anything. I just create a container with the help of that image. So this is the purpose. So this website is including its all its dependencies and all things. It is installed by itself, not by me, because it is written in our Docker file, and with that Docker file we create the image. Okay, so you can also access this from your internet. As far as I think, how you can access, you have to take the public IP address and put this IP address here, and port is 8080. That should work. No, sorry, is 80 only. I think so. Why it is not working? Okay, I think it's daemon is not started. Yes, service dot Apache 2. My service dot Apache. Let me check the status. Sorry, let's see. It is running. Okay, and it should be work.
Have you opened the traffic port in the AWS?
I have allowed all the traffic.
Yeah.
All the traffic is up.
Yeah. Anyhow. See. Now we can turn.
That should be work. Maybe some other issue, but in last class I have already shown you. Last session. Oh, no. Just the copy of the public IP address and 0. I think there is some issue. So currently we have some more things. I will show you. Actually, in last our Kubernetes classes, I have given the port number and the public IP address. Then you check that the website is running here. Okay. So in that session, I have shown you. Right now, I think there is some issue. Okay. So we have.
Hello. Hello, Rajiv.
Hello, Rajiv is not audible, I think.
Maybe some net issue is there.
Hello, Raju.
Yeah, please wait for some time. Maybe there is some issue at its side. Hi all, I have called Rajiv and there is some internet issue at his side. So let's wait for 5 more minutes. And if there will be some major issue, he will let us know. So we will plan this session again after some another day.
Okay, we will wait here.
Yes.
Hello. Nidhi, already the session is too long. Can we put some other day?
Yes, but let him
Just
come.
wait for 5 minutes.
Yeah.
If Rajiv is not connected, then we will quit the session right now. Okay, just wait for 5 minutes only.
Yes.
Hello.
Yes, Rajiv.
Yes, Rajiv.
Oh, I am so sorry. I apologize for that. I actually on Wi-Fi was suddenly
No, no,
got down.
it's
So now I'm
absolutely
connected.
okay.
Now I'm connected with my mobile phone. So,
If
so should
any
I?
issue connecting to Wi-Fi, then quit the session and we will join any other day. No issue.
Mm,
Yeah, Raju, already the session is too long.
yes, yes.
Okay, then put the next day is very good because other
Okay,
topic is also there.
Rajiv, according to you, how much time will you take to
I think
complete
it
the
will
session?
take. I think it will take the 20 to 25 minutes or 30 minutes
Okay.
more.
So I think we can give 30 minutes more because it will be
Yeah,
very
Rajiv, you
difficult to
can
select.
continue. It's 30 minutes left, so no issue. Please close today.
Yes.
Because our session is already recording. If someone want um, to refer this, whatever whoever have left this session. So
Rajiv, you can schedule in the evening if you can.
in
Otherwise, any
evening we
other day.
have another session actually at 6 o'clock.
Oh, yeah, we have another session from Rajiv, na?
Yes.
Mm.
So if you will say, then I can close it, and on the in the next week I will continue it with the
Yes,
other
sure.
things.
You
Okay.
can do one thing, Rajiv. You can please share this PPT and this command
Yeah,
file,
yeah, yeah.
the
I'm
training.
stopping the recording, and will share this recording, and rest portion for I will do another session for the
Uh,
half an hour.
Raju also shared the Docker command in Notepad.
Yes, yes,
Install. Okay,
definitely.
thank you. Okay, thank you so much. Thank
Okay,
you,
Rajiv.
everyone. Bye.
Thanks for the
Okay.